Hi everybody! Today we are talking about ratios with tape diagrams and comparing rates. As a reminder, you do not need to write down everything that is covered in this video, but be sure to jot down important information like key vocabulary words and at least one example of each type of problem that we cover. Remember that you can also pause the video to jot down important notes before moving on. You can rewind to review information again, and fast forward if you think you got it already, but be careful. Be sure that you don't fast forward too much and you miss out on something important. So let's begin with ratios with tape diagrams. Last time we talked about ratio tables and coordinate planes as visual ways to represent equivalent ratios. Today, we're going to show you a third way, which is tape diagrams. Now would be a good time for you to pause the video and write down this definition. I would underline it or bold it or even highlight it in my notes just to make sure that it pops out at me. So tape diagrams are when we use equally sized boxes to show a ratio. It's very important that you write down equally sized, because if the boxes are differently sized, then it's not going to be showing the same portion. You can fill out the boxes to also help you find equivalent ratios. So we'll go over an example. In this example, it says that the tape diagram compares the number of tables to chairs we need in the classroom. So if you notice in the tape diagram, it's in two different colors to kind of help you out, but they don't need to be in different colors. Just some people like to color one and give them different colors so that it pops. But the green tape diagram above shows two equally sized boxes. So we know that that is 2. The chairs is 1, 2, 3, 4, 5, 6, 7 equally sized boxes in that tape diagram. So the purple going across is one tape diagram. The green going across is another tape diagram. Some people like to draw their boxes super close to each other with a space in between. I personally like it so that all the boxes are connected and there's no space. But it really doesn't matter as long as it's clear that these are two different tape diagrams and that they show two different amounts. So from this tape diagram, we can see that there are 2 tables for every 7 chairs in the classroom. 2 tables for every 7 chairs in the classroom. So that's just another visual way to show a ratio. We're using tape diagram boxes in the tape diagram method. In the ratio table, we used a table, columns going up and down. In coordinate planes, we used the dot that connected 2 different amounts on the x and y axis. If the question asks you to triple the amount of tables, then you're going to have to figure out the equivalent ratio, because you want the ratio to stay the same between tables and chairs. So in this problem, they're asking, if we triple the amount of tables, how many chairs will we need? So they want you to take the number of tables, which is 2 right now, and multiply by 3. Remember, we want equivalent ratios. We can't just triple the amount of tables, because that means we have more kids in the classroom, but now we don't have enough chairs. If we triple the amount of tables, we also have to triple the amount of chairs to keep that comparison. So all we do in a ratio table is, a ratio tape diagram is that we triple the amount inside each box. So since we tripled the amount of tables, instead of 2 tables, oops, I found I had an error right there, 6. Instead of 2 tables, 1 and 2, we're now taking the 2 tables and we are multiplying by 3. 2 times 3 is 6. And here we also see 3 plus 3, is 6. So there, the tables are being tripled. If we do that, like we said, we have to do the same thing with the chairs. All we did was add 3's inside each of the boxes for the tables. So now we're going to do the same thing for the chairs. Remember, a tape diagram is a visual way for you to see the answer. So if this is confusing for you, you can always draw your tape diagrams, and you can just simply write in that multiplication factor. And if you want to count instead of multiply, tape diagrams are great for that. Instead of 2 times 3, it was 6. Or you could have added 3 plus 3, which is 6. Same thing here with the chairs. Instead of 7 times 3 equals 21, you could add 3 plus 3, which is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 3 still gets you to that 21. So that's tape diagrams. It's a third way to visualize your ratios. And I honestly love tape diagrams because, you know, just like now, you saw that I made a mistake. I thought it was 9, but in my mind, my multiplication fact was wrong. And so I double checked it by looking at my tape diagram, and I saw, wait, this is 3 plus 3, which is 6. So then I could go back and fix it. So it's just like another way to solve equivalent ratios. And if there's another way, that means that you can use that other way to check your work. Okay? So that's tape diagrams. Let's just do a problem to try it out. You can pause the video now and see if you can solve this problem on your own first. Okay, so in this problem, it says the school band bought cheese and pepperoni pizzas in the ratio represented in the tape diagram for their end-of-year party. It looks like we have a cheese and pepperoni tape diagram. I'm gonna have to count to see how much is in each. 1, 2, 3 for the cheese and 1 for the pepperoni. It's a 3 to 1 for cheese to pepperoni. Based on the ratio, how many pepperoni pizzas did they buy if they bought 6 cheese pizzas? So they're saying if it's 3 to 1 cheese to pepperoni and they got 6 cheese pizzas, we need to figure out how many, oops, I wrote it in the wrong spot. We got 6 cheese, I put it under pepperoni. We need to figure out how many pepperoni pizzas they bought. So normally, let me write it like this. You don't have to write it like this, but I like to label things so that I don't get it all mixed up. 3 to 1. 3 cheese, 1, 2, 3, and pepperoni 1. Okay, and 6 cheese pizza, so that's in the right category. And then we have the box here because we don't know how many pepperoni. All right. If we have 6 cheese pizzas, we have to think to ourselves, what number has to go in each of these tape diagrams? There's 3 boxes. I need to get to 6. So it can't be 1 because 1 plus 1 is 2, 2 plus 1 is 3. That's the original number that was in there. Let's try 2. 2 plus 2 is 4, 4 plus 2 is 6. So it looks like 2 is a number that goes in each of these boxes, so then that must mean that there's 2 pepperoni there. Another way you could have figured it out was with your normal method. 3 times what number gets you to 6? That's 2. So then 1 times 2 will also get you to the pepperoni. So it's just a visual way for you to figure out that number by making sure that it adds up to your number in the problem. So that would be 2 pepperoni pizzas. Okay. Let's try one more. Here, you can pause the video again to try it out. Here, Bellene is making garlands of popcorn kernels and berries to feed the wildlife. The diagram shows the ratio of popcorn kernels to berries Bellene uses on the garlands. So we have kernels to berries. We have 1, 2, 3, 4 kernels. For every 1, 2, 3 berries. So we need to complete the missing values on this table. So if I have 15 berries, I need to know how many kernels. And if I have 28 kernels, I need to know how many berries. Okay, let's start with this first one first. There's 15 berries, and there's 3 boxes for the berries. So what number has to go in each of these 3 boxes to get to 15? Well, we know 3 times 5 gets us to 15, so 5 should go in each of these boxes. So then it's 5 plus 5 is 10, 10 plus 5 is 15. So that means 5 goes in each of these boxes as well. We want to keep it equivalent. 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20. So we're really trying to figure out what number goes into that box. So this would be 20. You could do the same thing over here. 3 times what number to get to 15? 3 times 5. It's exactly what we did here. So now 4 times 5 gets us to 20. They're both different ways for you to figure out the answer. We love different ways in math because it means if we ever get stuck, we have more than one opportunity to get to the answer. Let's try the second one. There's 28 kernels. Now this 28 goes over here. Okay, there's 1, 2, 3, 4 boxes. So 4 times what gets us to 28? 4 times 7. So in each of these is the number 7. So that 4 times that 7 gets us to 28. Now that means we're going to put 7 on each of these boxes. There's 3 of these 7s. 3 times 7 is 21. So 21 should go in this box. How could we have done that a different way? 3 times what number? 4 times what number to get to 28? 4 times 7 to get to 28. 3 also times 7 to get to 21. So 7 was that magic number for this second row. So the answer is 21 here. Okay? So in both cases, you're looking for that same number that'll fit to make that number work, that amount work. So that's ratios with tape diagrams. It's basically equivalent ratios, but you can see it with the boxes. The other assignment is comparing rates. You've already gone over how to calculate rates, so now we're just comparing the rates. So let's do this one together. The table below shows the details of 3 different river rafting adventures. There's high tide. It lasts for 1 hour and you go 3 kilometers. There's monsoon. It lasts for 2 hours and you go 5 kilometers. And then there's the tsunami. It lasts for 4 hours. You travel for 14 kilometers. They all sound pretty scary. You're just like in a raft going down a river. So maybe this person wants to know which river rafting adventure offers the lowest average speed. Like, I'm kind of scared. Which one goes the slowest? Okay? So if you think about speed, whenever people talk about, oops, let me get my pen. Whenever people talk about speed, they talk about things like miles per hour, right? How far you go for every hour. The only difference here is it's not miles, it's kilometers. So it's going to be kilometers per hour. The order that that speed is set in tells us what to divide, because remember, rates tell us to divide. But order matters, okay? It's very important which number you divide by first. So here, it's telling us that we need to divide the kilometers first. The kilometer number has to go first. So for high tide, it's 3 for the kilometers divided by 1, the hours. For monsoon, it's 5, the kilometers, and 2 for the hours. And for tsunami, it's 14 for the kilometers and 4 for the hours. So for every single one, it's the kilometers divided by the hours. So I'm going to go ahead and do that on my calculator. 3 divided by 1. Oh, they have a calculator here for us, so we can use it on here. 3 divided by 1, actually, we don't even need to do that because it's just 3, so we don't need to do that. And then 5 divided by 2. Some of you may already know that answer in your head, but it's 2.5, 2.5. If you need the calculator, go ahead and do that. Use the calculator. And 14 divided by 4. 14 divided by 4. So we're going to always go in that order. 3.5, 3.5. Wow, so it wasn't what I thought it would be. It was actually this middle one. You would think that it would go in order, right? But it's not. That's why we have to make that calculation for rates. We can't just eyeball it and look at it and guess which one. It was the middle one. So it's monsoon that actually goes at the slowest speed, because this is 3 kilometers per hour. This is 2.5 kilometers per hour. And this one is 3.5 kilometers per hour. The slowest is monsoon. The fastest is the tsunami. I mean, that name makes sense, right? So it's monsoon. So remember, you're dividing always for the rates. For this comparing rates, they're going to have you make multiple divisions, division problems, and you're going to compare. That's why it's called comparing rates. You're comparing to see which rate is the fastest or the slowest or the greatest or the least. And then the order matters. Here it was speed. It's just like miles per hour. So that distance, the miles or the kilometers, has to be the first number you divide by. Okay? That's it for today. Let me know if you have questions, and if not, I will see you in class.